Hi guys, we're going to look at this topic, which is earth geometry. Now we'll only concentrate on paper 1 type of questions. Now I want you to be very careful when you're answering questions on this topic because it requires you to think. Yes, and most people make mistakes when they're dealing with this topic because there are different formulas that you'd use for when they ask you a question. Yes, so this topic, earth geometry, you're going to deal with what we call longitudes, how to find the position of a place. You're going to deal with the latitudes, so that is very important. And in paper 1, the common questions that would come on earth geometry are questions to deal with time, questions to do with distance, and questions to do with speed. Especially questions to do with time are very common in paper 1 type of question. So we're going to look at both scenarios where they draw for you the diagram, then you find the questions, you find the solutions, then you can also find solutions when they give you a question that do not consist of a diagram. So let us proceed into looking at examples. So we'll start with the first example. So that is the first example that we have there. How are we going to go about that one? So now look at this one. Town L is on 0 degrees, 30 degrees west, and town K is on 0 degrees, 60 degrees east as shown below. Now look at L is there, so it is running on this. It means there is a 0 degrees here, as this is called the equator. So there is a 0 degrees on this line here. Okay, now look at this one. Whenever we are giving the position of a place, we always start with the latitudes, then we'll go to the longitudes. Now I'll give you this homework. You should find out what latitudes and longitudes are. Alright, so if you're trying to give the position, you start with the latitudes, then you go to the longitude. So lat, longi. So that is what we do. So now look at this question. If a radio quiz is scheduled to start at 12 hours at L, so at L 12 hours, find the time at which the people at K will be listening to the quiz. So now I want to find out what will happen if a quiz is going to start at 12 hours at L. Now, what time will the people at K going to listen to the quiz? Now, here's the first point I want you to note. The point I want you to note is that this is a question on time difference. Time difference is dealt with longitudes only. So our interests are going to be longitudes. Now remember, I said it is latitude, longitude. So our interests are going to be longitude. Here, longitude 30 degrees west. Here, longitude 60 degrees east. So this is where I'm going to concentrate on. Now, since I know that I'm going to concentrate on longitudes, I'm going to find what we call the difference in longitudes. So, the difference in longitudes. So, how are we going to find the difference in longitudes? To find the difference in longitudes, you look at them. This is 30 degrees west. This is 60 degrees east. So, they are on different longitudes. This is west, this is east. So, if they are on different longitudes, add them. So we're going to say 30 degrees plus 60 degrees. So this gives us 90 degrees. So this is the difference in longitudes. After you find the difference in longitudes, proceed to find what we call time difference. Time difference is found by saying we get the difference in longitude, which we can say theta. So we can call it theta, then we divide it by 15. So now what are we going to do here? So we know to say our theta, which is a difference in longitude, is 90 degrees. We divide it by 15 because I'll show you one hour. So because we're looking at want to differentiate, we want to look at time and degrees. So now we're simply saying 1 hour is equal to 15 degrees. So if 1 hour is equal to 15 degrees, how many hours will be in 90 degrees? So I'm going to say 15 into 90. So how many times does 15 go into 90? It goes there 6 times. So therefore, in 90 degrees is equivalent to 6 hours. So I found 6 hours here. Now the question is that what am I going to do with the 6 hours? So I come back to the question. So the difference between L and K is 6 hours. Now the question I'm going to ask myself is that, am I going to add the 6 hours to 12, or I'm going to subtract it from 12? Now here is the thing. If we are moving from west to east, there's an increase in time. If we're moving from west to east, there's an increase in time. So you follow your compass, moving from west. So L is on the west side, then going to K on the east side. So there will be an increase in time. So we're going to add the 6 hours to 12. So to get the time at K now, so I'm going to say time at K will be equal to 12 hours plus 6 hours. So what is 12 plus 6 hours? So 12 plus 6, we get 18. So the final answer will be equal to 18 hours. So 18 hours will be the final answer. So that's one thing you should know. So moving from west to east, there is an increase in time, and the opposite gives rise to a decrease in time. Very important. Now let's look at the other one. What is the difference between L and K in kilometers? What is the difference between L and K in kilometers? Now look at between L and K. We're looking for the difference in latitudes. Now, how are you going to find the difference between L and K in kilometers? Now, there is a difference when they ask you to find the answer in kilometers and when they ask you to find the answer in nautical miles. Now, the difference comes in when you now concentrate. We're going to look at what we call the radius of the earth. So that one is very important. And also the formula might change. You'll see. So here we're going to use the following formula. So we're going to say theta over 360 multiplied by, so 2 multiplied by pi multiplied by the radius of the earth, then multiplied by cos x. So cos x degrees. So now let us try to find out what is each one of those. So now in this case, now what is the theta? The theta is the difference in longitudes. So what is the difference in longitudes? What we found here, the difference in longitudes, remember we had already found it, it was 90 degrees. So I'm going to put 90 degrees here. 90 divided by 360, then we're going to multiply 2. Now the pi that you should always use here is 22 over 7 because we're dealing with a paper 1 and you're not allowed to use a calculator. So the pi we're going to use is 22 over 7. Then we're multiplying with the radius of the earth. The radius of the earth is, when we're dealing with kilometers, it is 6,370. So 6,370. So kilometers. So you just say 6370 kilometers. So that's the radius of the earth in kilometers. Then we're multiplying with what? Cos x. Now what is x? X is just our latitude. Now look at both L and K are lying on the same latitude, which is 0 degrees. So it will be cos 0 degrees. That's what we have. Now, I should also mention to say, even if there is cos here, cos 0 degrees is simple to find even without using a calculator. So cos 0 degrees is simply 1. So the cosine of 0 degrees is 1. Right, so now, due to lack of space, I'm going to assume that you'll be able to simplify this whole expression. You should be able to simplify this. So you cancel the zeros where possible, then you proceed. Here I've already told you to say cos 0 degrees is equal to 1. Then you proceed in simplifying. If we are okay with simplifying, then well and good. If you have challenges with simplifying this type of things, you can let me know so that we can also look at a different what's this video that will talk about simplifications of such. So once you do the whole expression without using a calculator, you are going to find your answer to be so this will be that, so 110 kilometers, so 110 kilometers. So this should be the final answer. So I want you to try it out and you confirm if you're going to find the same answer. If you're going to have challenges, we can still look at it. So this is our final answer. Now we're going to look at another question so that we can have a good understanding on this topic. So let's look at another example. So we can say we look at the example number 2. So we have the following. A soccer match kicked off at 14 hours at A, so 20 degrees north, 30 degrees east. What would be the kick-off time of the soccer match at B, 20 degrees north, 15 degrees west? Before we start solving this question, one thing you should know is we're able to see that both A and B are on the same latitude. So the latitude is what? Is 20 degrees north. So even without me drawing a sketch of the earth, I'm able to imagine it. So they're lying on the same latitude, which is 20 degrees north, 20 degrees north. But what is the question saying? Now remember, when we're looking at time, anything to do with time, our interest to be what? Our interest to be longitudes. So our interest to be longitudes. Now let us look at the longitudes. So this is 30 degrees east, 15 degrees west. The first thing that we're going to do here is we're going to find the difference in longitudes. So let's start. So part A, the first thing, we're going to find the difference in longitudes. And I've said this is 30 degrees east, this is 15 degrees west, so they are on different longitudes. So you add different longitudes, you add, so it will be 30 degrees plus 15 degrees. What do we get when we say 30 degrees plus 15 degrees? We get 45 degrees. So 45 degrees. Then let us find the time difference. So how do we find the time difference? To find the time difference, you get the difference in longitudes, which is 45 degrees, then you divide by 15 degrees so that we can find the time difference. So we get 15 into 45, it goes there 3 times, so the time difference is 3 hours. Now the question we ask ourselves is that should we add 3 hours to 14 or we subtract 3 hours from 14? So let's first understand where are we moving? So we are moving from east to west. And what happens if we're moving from east to west? Remember, I told you to say if we're moving from west to east, there is an increase in time. Now we are doing the opposite, moving from east to west. So there is a reduction in time. So instead of adding the 3 hours to 14 hours, we're going to subtract it from 14. So we're going to say, to get the total time, so we're going to say 14 minus 3, and 14 minus 3 is 11. So the final answer will be 11 hours. So 11 hours will be the time at B. 11 hours will be the time at B. So that has been dealt with. We look at B. Two towns P and Q are on the same longitude. Okay, same longitude. Given that P is that and PQ is that. So here they've given us, this is a distance, right? So once you see this is a distance. Now on earth geometry, there are only two formulas for distance. Distance can be measured in kilometers or it can be measured in nautical miles. So here they've given us distance in nautical miles. Alright, so then they are saying find the position of Q. So what are we going to do? So to find the distance, PQ when it is in nautical miles, so the formula that you can use is the following: theta times 60. Now this formula can only work when you are dealing with the nautical miles. So this formula can only work when you are working in nautical miles. If you are working in kilometers, you can't use this formula. So therefore, PQ, they've told us to say PQ is 7,200. So you put 7,200 here. Then we don't know our theta, multiplied by 60. Alright. Then we're going to divide by 60 here. We're going to divide by 60 there. The 60 is gone, the 60 is gone. 0 is gone, 0 is gone. Then theta will be equal to, how many times does 6 go into 720? Or in short, how many times does 6 go into 72? So you're going to discover that 6 goes into 72 12 times, then you just add a 0. So it goes into 72 12 times, then you just add a 0 so that you can make it 120. So this becomes 120 degrees because of the 0 that we had remained with. So we have found the value of Q. So what is Q? Now, so here they're saying this is theta, I mean. So this is our theta. Now what is our theta? Our theta now is the difference. So we're looking at theta now. So I'm saying our theta now is the difference in latitude. Now here is the thing I want you to get. They are saying these two towns are on the same longitude, right? So the longitude is the same. So this simply means whatever Q is, so whatever Q is, the latitude we don't know it, we're going to put X degrees, but the longitude, no matter what, we know that the longitude will be 15 degrees. 15 degrees what? 15 degrees west. Why am I saying 15 degrees west? Because the question is saying they are on the same longitude. So now I've gotten this longitude. So meaning whatever I'm calculating for now is for the latitude. Then how do I find for the latitude? To find for the latitude, I already have the difference in latitude. Now if the difference in latitude is 120, and I've already been given one of the latitudes, which is 40. So I'm going to simply say, okay, if I say x plus 40, if I add these two, the answer I should get should be 120 degrees. So then we know when this 40 crosses the equal sign, x will be equal to 120 subtract 40. Then 120 subtract 40, we get 80 degrees. So now, this is 80 degrees what? In order for us to add these two, it means they should be on different latitudes. Now, there are only two latitudes. There is north and south. If 40 is on north, then 80 automatically will be on south. That's how it becomes. So now we're going to say our Q now, the position of Q, so therefore the position of Q will be, the latitude is what? The latitude is 80 degrees, so 80 degrees south. The longitude maintains to be 15 degrees west. So meaning that one has been dealt with. That is how you can do that. Now let us look at a final question that will cement our understanding. We look at that other question. Now the question reads, the difference in longitude between town A and town B is 105. So this 105 should be a degree, so it should be 105 degrees. B is west of A. Then we are saying a family at A was watching a football match at 16 hours. At what time did a family at B watch the same match? You need to be very careful when solving such. As you can see, we are looking at a question to do with time, especially that we've not been given the earth, the diagrammatic representation of the earth, but we can imagine it. They are telling us to say the difference in longitude between these two towns is 105 degrees. So if the difference in longitude, now remember, time difference, we always deal with longitudes. They've already told us to say the difference is 105. So we just proceed to find what we call time difference. To find time difference, we get the difference in longitude we found, which is 105, then we divide by 15 degrees. So how many times does 15 go into 105? So 15 goes into 105 7 times. So the time difference is 7 hours. So the question we should ask ourselves now is that, are we going to subtract the 7 hours from 16, or we're going to add the 7 hours to 16? So what are we going to do? Now, we have a guide here. We have a guide. The guide is that B is west of A. That's a guide. B is west of A. Now what do you understand? So they're simply saying B is on the west side. If B is on the west side, it means A is east of B. If B is west of A, then A is east of B. So now what are we going to do to find the time at B? So to find the time at B, since B is west, so it simply means it's something like this. We're looking at something like that, where A is this side, B is this side. So we are moving from A to B. So if we're moving from east to west, there is a decrease in time. So if there is a decrease in time, then we're going to subtract 7 from 16. So we're going to say the time at B will be equal to the 16 hours. We subtract the 7 hours that we found. So we'll do this. So time at B will be equal to 16 hours, subtract the 7 hours that we found. And if we say 16 subtract 7, what do we get? We get 09 hours. So we get 09 hours. So 09 hours is the time that we are finding there. So hope you are able to follow and get the concept. Now at this point of time, we're going to look at part B and see what they're asking us to find. The distance between P and Q is 3,600 nautical miles. If an aeroplane flies from P to Q at 600 knots, now you know already when we say nautical miles, we're looking at distance, That's distance. That we are clear. But what should come in your mind when you see the word knot? Knot is a unit of speed. So knot refers to speed when distance is in nautical miles. So knot refers to speed when distance is in nautical miles. How long will it take? So that is time. So when there is this distance, there is speed, and there is time, the formula that we are supposed to use is the following. Speed is equal to distance over time. That's the formula we're going to use. Now speed, they've given us that to be 600 knots, so we're going to put 600 here. And distance, they've given us to be 3,600. You put 3,600. Then where there is time, you just put t because we don't know. Then we can say over 1 and we cross multiply. So what is 600 times t? This will be 600 t. 1 times 3,600, it will be 3,600. Divide by 600, divide by 600. The 600 and the 600 is gone. Then our time will be equal to 2 zeros are gone, 2 zeros are gone. Then 6 into 36, it goes there 6 times. So the time is in hours, so time will be 6 hours. So that is how you can find the time when they've given you speed and distance. Yeah, so it is also important to note that the distance has been given in kilometers, then speed will be in kilometers per hour. So those are the units of speed. Now that you've fully gotten the concept, as usual, you're going to look at 2 questions that you can attempt. So the first one is the following. So ensure that you read and understand this question. Then you also look at the second one, which is the following question. You also read and understand this question. Thank you.